Right. I got these final review problems.
Yeah, I was wondering if we could go over the final review for like 30 minutes and then go over the calculus unit I'm having for the remainder of the 30 minutes. That's cool.
Certainly.
All right, sounds good.
You tell me when you want to switch over. If I happen to notice it's close to 5 o'clock, I'll say it's time to switch to your calculus stuff.
All right, sounds good.
Let's see. Are we supposed to do all the circled ones? Is that what we're doing here?
I don't know. I think we're supposed to do all of them.
Okay. These first ones. Determine whether the equation represents y as a function of x. 1 minute. Hold on a second. I just make sure that I didn't have a double scheduled here. Wow. Oh, yeah, hold on.
Oh.
That's correct. Period. Sorry. Wrong Nick. Period.
No.
I originally had a session scheduled at this time, and they canceled it, and then you scheduled, and then I realized, gosh, I hope that the brother took the later one. It's complicated, but let's look at 33 first. Okay? In 33, y is definitely a function of x.
Mm-hmm.
In other words, hold on. Because I can write it y equals square root of 1 minus x, then I can also write that like that. Okay? So that one's totally clear to me. If we look at 34, is that crossed out for some reason?
I have no clue. I think we just go over all of them.
Okay. Well, 31 I'm actually puzzled by. I'm not quite sure what they're looking for. In other words, I could solve this for x. In other words, I could say x equals y to the 4th divided by 16, and then what we have is a function of y. But I suppose I could also solve it for y. The problem is if I solve it for y, I have y to the 4th equals 16x. And if I take the 4th root of both sides, I get plus or minus 2x to the 1/4. So it's not a function of x. Now I'm getting it. Yeah, now I'm understanding what they're asking for. Yeah. In other words, a circle is not a function of x. And anytime you have both the plus and the minus, then that function's going to look something like that, where it does not pass the vertical line test. And the fact that when I solve for y, I end up with a plus or minus means it has to not pass the vertical line test. So there's no way that is called a function. Now on 32, I can solve it. I get y, if I move it to the other side of the equation, I get this. Well, that's a function of x. In other words, I could replace the y with f of x. Same thing with 33. 34, on the other hand, when I have absolute value of y equals x plus 2, that means two different things. What does it mean? Either y equals or what?
I have no clue.
Well, it equals the positive In other words, the first part of that or is always exactly what you're looking at without the absolute value sign.
Or x minus 2?
Well, it's the negative of x plus 2, which is minus x minus 2. And again, we have two different functions. We have this function or we have this function over here. So I cannot say that y is a function of x, at least not by my definition. Again, these kind of problems are new to me. I can't say that I've ever run across a problem like these. I'm not 100% sure, but I'm 90% sure that 33 is, and 32 is, but 31 and 34 are not. All right, let's look at 35. These are relatively straightforward. In other words, if I have my function of x equals x squared plus 1, then what is f of 2 equal to?
5.
What is f of minus 4 equal to?
17.
What is f of t squared equal to?
T to the 4th plus 1.
Good. And what is negative f of x equal to? Here's f of x.
Is that just the inverse function?
It's not inverse, just the negative. So what I'm going to do is I'm going to put, in other words, there's f of x, right? There's negative f of x.
Okay.
Now take away the parentheses and you have minus x squared minus 1. All right, 30.
How do you know an inverse then?
I'm sorry, what?
How does it, like, what's the symbols for an inverse then?
It's this.
Oh, okay. Okay. Sorry, I just got this confused.
Yeah, and inverse is completely different, actually, as to how you come up with the inverse. You switch the variables and solve for y. Let's look at 36. The function is x to the 4/3. And they want to know what g of 8 is. How do you do this? How do you take 8 to the 4/3?
Is the bottom power the root, or is the top power the root?
The bottom is the root, the top is the exponent.
So
and you always do the bottom part first.
So it'd be, so first the bottom part would make it 2.
Correct.
And then 2 times 2 is 4, times 2 is 8, so 16.
Correct. Notice, if you do the top part first, you're going to get the same answer, but you're going to need a calculator to get it. Because 8 to the 4th is going to be 64 squared, and then you're going to have a huge number that you have to take the cube root of. So, and all of these kind of problems are always set up like this, where you always want to do the bottom part first.
But you can do either one first.
Yes, technically.
Okay.
What is g of t plus 1?
T plus 1 in parentheses with the 4/3.
Yep. That's all
they
do. Whenever they stick something in the parentheses other than x, just substitute it wherever you see x. What's g of minus 27?
-3. This would be 9, 27. I don't know the last one.
81.
81, thanks.
Is it positive or negative?
Positive.
Okay. Interestingly enough, what do you suppose that is?
4?
Not according to Wolfram Alpha.
Why is that?
Good question. I tracked it down and did a ton of research. It has to do with taking negative numbers to certain types of fractional exponents. The answer is a complex number. And it has to do with really higher mathematics, but a lot of teachers don't recognize this. And they would say 4 just like you did. But I guarantee, I've done this 100 times. If I bring up Wolfram, are you familiar with Wolfram Alpha?
Yeah.
Yes or no?
Yeah, I am.
Okay. If you put in -8 in parentheses to the 2/3 power, it will not give you 4. It gives you an imaginary number. And I looked it up, and there is a reason for it. And the bottom line that I found is you cannot take a negative number to a exponent if the numerator, if it was 1/3, you could do it. In other words, 1/3, that's equal to -2. But when you get 2/3, all of a sudden it changes the rules. And we don't have time for me to go into it or explain it, but it might affect the answer on G. Because that's pretty much what we're doing when we take -27. There's our negative number, and we're taking it to the 4/3. The cube part gives us a -3, and then we take it to the 4th power and turns positive. I bet you Wolfram Alpha doesn't tell us that that is 81. It'll take me 2 seconds to pull it up. I'm just very curious about this, and it has kind of bothered me because I've never fully understood it. It has to do actually with very sophisticated math. Whoops, hold on. That was supposed to be a parentheses. All right, that was the problem, right? See the answer it gives us? -40 minus 70i. It does not give us 81. In other words, it does not give us -3 to the 4th power. Here's the result. It's -81 times the cube root of -1. Well, you would think that would be -1 times -81, so you get 81 as a power. How come they don't say 81? That's what bothers me. And they give a decimal approximation that's an imaginary number. I don't know. Certainly, it wouldn't surprise me if 81 is the answer here. But notice Wolfram Alpha didn't give it like that. I don't really know why.
That's interesting.
Yeah, it is kind of interesting. Always be wary when you're taking negative numbers to fractional exponents. Now number D, I guess it would be -x to the 4/3. Right? In other words, Whatever's in the parentheses, you plug in for x. That's what I did. All right, 37. All right, these are pretty easy. H of minus 2, which function is that? The top one or the bottom one?
Bottom. No, yeah.
Always
Okay.
look at this part first. Whenever you're analyzing a piecewise function, start with your domain. In other words, whenever x is less than or equal to minus 1, I'm going to use this top function. Well, here we have x equals minus 2. That's less than minus 1. So it's the top function. So what's the value of h of minus 2?
That would be negative 3.
Okay. What's h of minus 1?
Negative 1.
So you're using the top, yeah. H of 0.
2.
And h of 2.
6.
Like I said, those are pretty easy. 38. Wow. Never seen exercises that get easier with each problem. What's f of 1? Unless those others are a lot harder. In other words, if I'm really right on that, then these are very strange answers. Maybe the answer is that, I don't know. I was thinking maybe the answer is minus 3 times the cube root of minus 1, like they gave it in Wolfram Alpha. I don't know. Maybe there's multiple solutions, and there's a complex solution in addition to the other one. That's a hard subject to do research on. I looked it up on Google. I typed in negative numbers to fractional exponents, and I actually found a page that said you can't do it. It's not quite like dividing by 0, but it kind of fits in that category. Or probably more appropriately, like taking the square root of a negative number, because you do get a complex answer for some reason. What's f of 1?
Negative 3, negative 1.
F of minus 2.
Negative 1/3.
F of t.
3 over 2t minus 5.
And f of 10?
1/5.
It's the domain in 39.
All real numbers.
40?
I don't know how to do that without a piece of paper.
Okay, whenever you're talking about domain.
Oh, that's all real numbers too, actually. I was thinking about range.
Okay. Correct, you're right. Range would be harder on both. In other words, we'd have to graph that and see where the vertex was in order to figure out what the range was. But they're not asking about it, they're just asking about domain. 41. How do I solve for domain in 41? What equation do I need to solve?
I don't know.
You take whatever's in the radical sign. That has to be greater than or equal to 0. That's how you solve it. And then you solve this inequality. Now,
So it'd just be 5?
No, it's actually going to be minus 5 through 5. If you think about this, as long as x is, in other words, that's always going to be positive, right?
Yeah.
In fact, let's move that to the other side of the equation. Now we take the square root of it. Well, the other thing about inequalities is you know that they're a lot like equations, except when you multiply or divide by a negative number, you have to turn the sign of the inequality the other way, right?
Mm-hmm.
Same principle when you are taking the square root of both sides. In other words, I end up with x is indeed less than or equal to 5, but I also end up with x is greater than or equal to minus 5. In other words, if this was an equation, it would be x is equal to plus or minus 5. It's an inequality, so instead of being able to say x is less than or equal to plus or minus 5, for the minus you have to turn around the direction. And if you think about it, that's got to be the correct answer. As long as x is between those two values, then that is a positive number or 0. In other words, if you plug in minus 3 for x, you have 25 minus 9.
Okay.
So the solution would be graphed like that. But the really important part of this problem is understanding how to handle an inequality where you have to take the square root of both sides. Let's just go through that one more time. If I say x squared is greater than or equal to 4, and I take the square root of both sides, what are my two answers?
X equals, x is greater than 2 and x is less, no, x is greater than negative 2 and less than negative 2.
In other words, the first part is pretty normal, right? Doesn't even involve a plus minus here. The first part is just take the square root of that, take the square root of that, leave them both positive, and you get that. The second part, involving the minus solution, just switch the sign. And if we check, this is clearly true. In other words, if x is 3, this is a true statement. If x is minus 3, that's a true statement. Have you had interval notation, or are you supposed to give answers in interval notation?
Yeah. I know how to do that, though. We practiced a lot at the beginning of the year.
Okay, so in this particular problem, that's the answer, with brackets on both, not parentheses. 42. How am I going to solve 42? So what's the first thing to write?
X squared plus 8x is greater than 0.
Greater than or equal, because you can take the square root of 0. Okay? Now, solving this, what's the first step?
Would you take an x out?
Yes. Now, you have this, and this is a particularly, actually tricky thing to solve for. You have to use what's called a line chart. You know what I mean by a line chart? First,
no.
Well, the first step is figure out your critical points. What are your critical points? And the critical points are whatever makes the numerator or the denominator 0. Because sometimes you'll have a quotient here instead of a product. And the quotients are really tricky. The products aren't that hard to figure out. You could almost do it instinctively, but we'll use the critical points. So what are my two critical points?
Would it be 0 and negative 8?
Now, we mark those on the line chart. And we take any number to the left of minus 8. Pick one.
Negative 8.
To the left of minus 8.
Negative 10.
Okay, when you pick negative 10, that's negative. That's negative. When I multiply a negative times a negative, I get a positive. So anything to the left of negative 8 is plus. Now pick a number between 0 and minus 8.
Negative 1.
Okay, again, that's negative, but this is now positive. Negative times positive is negative, so all of these are negative. And pick a number greater than 0.
1.
That's positive, that's positive. Positive times positive is positive, and now we're ready to answer the problem. And the solution is negative infinity to negative 8 in combination with 0 to infinity. In other words, just like this, negative infinity, negative 8 with a bracket, because it's greater than or equal, in combination with, again, 0 to infinity. So this would be the way. In other words, once you have intervals as your answers, then you're almost forced to use interval notation. It becomes very difficult to represent the answer without interval notation. Now, if this problem was less than or equal to 0, then clearly I would choose that as my solution set, where I have all the negatives. And these problems can get somewhat tricky. In other words, if I give you a problem like this, not that easy to figure out, right?
Yeah.
But if I find my two critical points and go through the line chart analysis, and I just pick wherever the line chart shows me to be positives. So our domain on that one was, I wrote it in interval notation, negative infinity to minus 8 in combination with 0 to infinity. Any of those values make what's inside that radical greater than or equal to 0. What's the domain on 43?
All real numbers except for s equals 3.
Okay, 44?
All real numbers except for x equals 4/3.
Negative 4/3.
Negative 4/3, yeah.
In other words, again, where you'd start there, rather than trying to just figure out the answer in your head, start here. Make 3x plus 4 equals 0, because we know that's the only thing that won't work for x. And then if you solve that, you get negative 4/3. Okay. All right, we're halfway through. You want to go to your calculus stuff?
Yeah, that sounds good. Well, what problem did we leave off on?
44.
All right, thank you.
We can do whatever you want. We can stay on this if you prefer, but I was just reminding you that you had said you wanted to look at some calculus stuff.
Calculus has been kind of tough, so I was wondering if we could.
Okay. Is it stuff you can verbalize, or are you going to need to send me something?
Can I just send you pictures of it?
Sure. These actually work a little better, I think, than that. Well, maybe not better, but they work fine. In fact, I'm not quite sure where your mom gets that. She must log in. I don't know. Yeah.
I got your number, so.
Call her when you've sent it.
Yeah, I'm just going to send you the...
Send one picture only.
Okay.
And then while we're working on that one, you can send another one if we'll have time for 2 pictures.
Okay. I just sent you the picture of the first problem.
Okay.
And then I'll give you what the instructions were.
Okay. You sent it to David Cowan 1949 at Gmail?
I just sent. Oh, sorry, I just sent it to your phone.
Yeah, send it to my email if you could.
Email pulled up.
It's, yeah, you've sent it before, so I think if you just type DA, it'll give you the default David Cowan 1949 at Gmail.
Yeah. I just don't have.
Let me see.
I just don't have I just got a new phone, so I don't have Gmail set up on it yet.
Okay. Unfortunately, when you sent it to my text, it came through as a downloadable file.
Oh, here, I'm downloading it. It should take like 2 seconds.
Yeah, so I'm not even sure I know how to view it on my phone or forward it. I guess I could probably
Yeah, it's okay.
forward
It's down right here.
All right. Is it an Apple phone or is it a Samsung?
It's an Apple phone.
Okay. I don't have an Apple, but and I do have some Apple or iPhone users that they end up sending it in the body of the email, and you don't want to do that. You want to attach it as a large image, as an attached file. Not a small image. If it's a small image, I won't be able to read it when I blow it up.
Okay, sounds good. What's your email again? Sorry.
Here, I'll write it. $19.49 at Gmail.
Okay. We gotta take. Sorry, it's taking a while.
All right. I was going to say, let me look at that other material and see if I see anything interesting here while you're sending it. When you sent it, holler. But in the meantime, I'll take a gander at some of this other stuff here.
Okay, I sent it.
Okay. Yeah, there it is.
Okay, and then I can give you the instructions for what A, B, and C mean.
Okay.
Okay, so A is find the slope at the given point on the curve.
Okay.
B is the equation of the tangent line at the given point, and C is the equation of the normal line at the given point.
Okay. All of that sounds really hard, but it's not. Pretty easy. First of all, when you're writing equations of the lines, what's the most important part of an equation of the line?
Don't know.
There's your standard equation of the line, right?
Yeah.
What's the most important part of that?
The slope?
Yes, always. Slope is the first derivative. So if I say, you've had first derivatives, I assume?
No.
It's the only way you can do this problem.
I know how to derive. I kind of know how to derive the problem. You like multiply the.
Right. It's 3x squared plus 2 is the first derivative of that function.
What happens to -3?
That goes away. When you take the first derivative of a negative number or of any number, it's 0.
Okay.
The reason is that if I have y equal 3, or -3, it's a horizontal line. The slope of that horizontal line is 0. The derivative of all numbers is 0, no matter how big or small the number is. But the most important thing to remember is the derivative means slope at that point. So if I want a numerical answer, you said A asks you for the slope at that point, correct?
Yeah.
Okay. So plug in the x coordinate -2. In other words, they're saying, what is the slope of the line right there? That's 14. -2 squared is 4, times 3 is 12, plus 2 is 14. So the slope of that cubic function at the point -2 is 14. Now, B says, what's the equation of the line that's tangent to that curve at that point? Well, you're familiar with two different formats for the equation of a line. There's slope-intercept, which is y = mx plus b. But there's another one called point-slope, which is easier to use in calculus. And here's what point-slope format is. And notice, if you ever forget it, notice what m is. The difference in the y's minus divided by the difference in the x's. In other words, rise over run. Okay? So if you didn't have this memorized, that should be a little helpful. Now, the equation of the line, I'm going to plug in the y1 of -7. I know the slope is 14. And this is x minus a -2. There's the equation of the line in final format. Unless it's specifically asked for it in slope-intercept, then you are permitted to give it in point-slope format, which is, as you'll see, that was a one-step process. In other words, once I figured out what the slope was, now it's just a question of plugging that in for m and these 2 points in for x1 and y1. Question C said, what's the equation of the line normal to that? Correct?
Would it be -1/14 x plus 2?
Yes. In other words, it's the same as what I've got here, only it would be -1/14 as the slope.
Okay.
The perpendicular slope is always the negative reciprocal of the other one. And the points are the same. In other words, this is still a line that goes through that. Now, let me just, for clarification's sake, the point they were talking about was -2, -7, okay? So let's see, we had a slope of 14, so the curve must do something like that. So let's pretend the curve does that, without graphing it on a calculator or anything. The reason I have a pretty good idea is because I know the slope is 14, right? Well, that's pretty steep. I meant to draw that pretty steep. A 14 slope is a steep slope. And it's the slope of the tangent line at that point. That point being -2, -7. And then the line that's perpendicular is going to look like this, going through the same point. Well, that has a slope of -1/14. And it goes through that same point. All right. What's the bottom part here? here we have this. All same three questions, only this function.
Yeah.
Here's the thing about calculus, Jay. One of the best ways to think about calculus is its manipulation of functions. And I heard it described once the following way. Algebra is the manipulation of numbers, right? Excuse me. Arithmetic is the manipulation of numbers. Algebra is the manipulation of variables that represent numbers. And calculus is the manipulation of functions. So when I take a derivative, I'm always manipulating the function. Now, if I want to take the derivative here, a better way to write this is like this. In other words, you must know the power rule, right? We use the power rule on that last function. Very easy to take the first derivative for certain types of functions. If it's a simple polynomial, you can always use the power rule. Well, I converted that x so that it has an exponent so that I can use the power rule. So what's the derivative of that?
Would it be negative 2x to the negative 2th power?
Yes, which is the same as this, but we don't need to write it this way. We can write it that way and use that as our answer, but both of those are the same. And the point we're going through is negative 1 comma negative 2. So what is the slope? What is f prime of negative 1? In other words, to figure out the slope, you always plug in the x value.
So it'd be it would be negative 2 over 1?
Yes.
So negative 2.
That's the slope. Now we're ready to do everything else. Now using point slope formula. Now I don't have to use point slope. I could use y equal mx plus b. Let me demonstrate how I would use it using y equal mx plus b, in case you forget point slope. But I would advise you to memorize point slope. There's not very many times pre-calculus that you need point slope formula, but it works so much better in calculus. It's a one-step process, whereas this is going to be a two-step process. In other words, I know that the slope is minus 2, so I know this much of it. And I know it goes through that point. So I can plug in the y-coordinate and the x-coordinate, so I get negative 2 equals minus 2 times minus 1 plus b, and I can solve for b. b equals minus 4. Now I know the equation of the line. The equation is y equal minus 2x minus 4. So that's another way to do it. But notice that it was 1, 2, 3 steps. Whereas if I want to do it using point slope being y minus y sub 1 equals m times x minus x sub 1. I can do it in one step. Y minus a minus 2 equals minus 2 times x minus a minus 1. There's the answer, one step. So in calculus, you're kind of always, you repeatedly have to do this because they're always asking you for the equation of the line. And it's a one-step process when you use point slope. It's a three-step process if you have to solve for b. Either one is the same. Notice that if I distribute here, move the 2 over, what I get? I get minus 2x, minus 2 minus another 2. So I get the same answer as I got using the y equal mx plus b, and it has to be the same equation. It just doesn't have to be written in slope-intercept format. And in fact, if they're ever in calculus going to ask for a specific format, they're going to ask for point slope because that's what everybody uses. It just can be problematic if you don't have both memorized. So make sure you know slope-intercept format and point-slope format.
Okay.
And then in terms of what would the perpendicular line equation be? Use the one I have.
It would be
Go ahead.
y plus 2 equals 1/2 x plus 1.
Yeah. And you can leave it like that. In other words, you don't have to do anything more here. You do not have to simplify this. That is the proper answer, actually. That's a better answer than y equal minus 2x minus 4.
Okay.
All right. Did you send the other page yet?
I think I'm doing pretty good with this stuff now, actually. That makes more sense.
Okay, good. Yeah, the power rule can always be applied whether the x is in the denominator or the numerator. Just always put it to an exponent. If it's a negative exponent, fine. Doesn't matter. You still can apply the power rule.
Okay.
Incidentally, there's 4 rules in differential calculus that you're going to run into. The power rule is one. Product rule is the next one you're going to get. Quotient rule, and then the chain rule. And between those 4 rules, you can differentiate any function. Not so with integral calculus. Going the other way, and integration is absolutely the inverse of differentiation. In other words, here's what I'm saying. If y equals x cubed, y prime equals 3x squared, well, the integral of 3x squared better be x cubed. And it is. In other words, to take the integral of a polynomial, you add 1 to the exponent and then divide by the new exponent. So the integral of this is the same as the derivative. Well, no, I mean, the derivative of that is that, the integral of that is that. It's an inverse procedure. But, and here's the kicker, integration is an 8 on a 10-point scale. Differentiation is a 2. And you might wonder why that is. You don't have these rules. You got 4 fairly simple rules to handle differentiation, but when you get to integration, it's like a semester course for every single method, and there's like 8 methods that I know of for integrating a function. And none of them are easy, like 4 rules for differentiation. It's kind of an odd thing as to why integration would be so hard.
Mm-hmm.
All right, so let's see. We want to go back to that other page we were on?
Yeah, if that's cool with you.
Sure. And pick up with 45.
Yeah.
We can pick up wherever you like, but if you want to go in order.
Right.
Some of these might be a little more useful to you. In terms of calculus, it's huge knowing where the function is increasing or decreasing. In other words, things that I'm seeing on questions 57 through 60. But that's okay. Let's look at 45. 45 is not bad either.
Hello?
Yeah, no, I was just reading the paragraph.
Oh, sorry.
Okay. So if before you can write an equation, which is what they're asking us to, as a function of x, x is the number of units that are produced. Okay, so let's define that. X is the number of units produced. Okay? And the cost function as a function of x, we'll write it like that, is it's a variable cost of 535 times the number of units per unit, so that's x, that's our variable cost, plus a fixed cost of 16,000. So there's your cost function. Okay? What's the revenue function?
It would just be 8.2x.
Yeah. What's the profit function? Profit's always going to be revenue minus cost. So what's profit going to be? I'm surprised they didn't have a part in between here that said, what's the revenue function? Because you can't really write a profit function until you write the revenue function. But do you know how to subtract one polynomial from another? What's the profit function end up being?
Would it be 8.2 minus 5.35?
Yeah, what is that? 2.85x plus 16,000.
Would it be minus 16,000?
Excuse me. Yes. I just was about to correct myself when you corrected. Minus 16,000. And there's your profit function.
Okay.
$46. Let's skip maybe. In other words, the problem with word problems is they take too long to do, and some of these other are actually going to be more useful and valuable for you. Wow. So as you've no doubt know by now, there's a hard way to take derivatives and an easy way. This is the hard way.
Oh yeah, we did the hard way yesterday.
Okay, let's do the hard way at least once here. But here's what first derivative is, or derivative, is defined as, mathematically, as the limit of f of x plus h minus f of x all over h as h goes to 0. So when we're doing a problem like this, let's figure out, first of all, we know what f of x is, right? What is f of x plus h equal to? That's what we have to always do for starters. It's the first term.
F of x plus h.
Just fill it in. In other words, don't try to do the whole thing in your head. Remember what the rule is. The rule is whatever's in the parentheses, you plug in for x.
Okay. So it'd just be 2x
Well, let's don't get ahead of ourselves. 2 times the quantity x plus h squared plus 3 times the quantity x plus h minus 1. Okay. Now we do have to expand that. In other words, we do need to simplify that. Before we can subtract f of x, we need to expand all of this. You'll see why once we do it. So first of all, expand x plus h squared. That's something you want to be able to do without having to FOIL it. This gets back to what I was saying, I think it was to you the other day. When you're taking an a plus b squared, memorize what it is so you don't have to FOIL it each time.
Yeah.
What it is x squared plus 2 times x times h plus h squared. Okay? With me?
Yeah.
Okay, now I'm going to distribute that. So I got 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1.
Wow, okay. Some of them cancel out.
Can't really combine anything there. Nothing cancels out. Oh, hold on.
Wait,
Not yet.
not yet.
Remember what that is. That's f of x plus h. That's only that part there. So from that, I have to subtract off f of x. Well, f of x is the quantity 2x squared plus 3x minus 1. And if I remove those parentheses, I have to distribute the negative sign to all terms in the parentheses. Now, what always happens on these, every single time, is that every term, this is the entire numerator, right? Every single time, every term that does not have an h in it cancels. In other words, I've got a 2x squared cancels with the negative 2x squared. I've got a 3x cancels with the negative 3x. I got a negative 1 cancels with the positive 1. Everything else has an h in it. So now I have this. 4xh plus 2h squared plus 3h. But remember, I'm dividing it all by h. And I'm taking the limit of this as h goes to 0. Well, remember what happens. Notice that if I do a direct substitution, I get 0 divided by 0, right?
Mm.
But every term in the numerator has an h in it.
So can't you substitute that out?
Yeah, so I can factor one of those out and cancel with that. I factored out an h. So now what I'm left with is 4x plus 2h plus 3. What is the limit of that expression as h goes to 0?
4x plus 3?
Correct. Notice that that's what you get if you use the power rule. 4x plus 3. You see what I mean by using the power rule?
Mm-hmm.
That becomes 4x, that becomes plus 3, that goes to 0. So this is by far the harder way to do it. You might ask yourself why they make you do this. And that's a good question. I personally don't think it's the way to begin calculus. It's kind of like dropping you on the expert slope and saying, here, let's teach you how to ski. Instead of starting you on the beginner slope and saying, we'll work up to the expert slope. Well, the power rule is really, really simple, and so really is the product rule, quotient rule, and chain rule. The hardest of all of it is this limit difference quotient that they make you start calculus with, which is crazy, but that's what they do. And the thing to realize, I unfortunately got to go at 5:30, I have an appointment, is always, in other words, you always know what f of x is. So the very first step is always this step here, and spell it out just like I did there. Write it just like that. Don't try to do 2 steps in one.
Okay.
And then just expand each one gradually, and just keep going like I did. There's a lot of terms there, but always know that when you get done, everything that does not have an h in it is going to cancel out. And you're only going to have terms that have an h, which can be factored out and canceled with the h that's in the denominator. Mm-hmm. Once you get that concept, these aren't so tough. These become easier to do, although there's some that are still pretty tough. In other words, if you try doing this with this function here, it's a lot more difficult algebra. But it can be done. In other words, but they're tougher than just straight polynomials. Straight polynomials tend to work out exactly as that one did, very easily. But as soon as you get something that's a little harder, well, now notice we're going to have 1 over x plus h minus 1 over x, all divided by h. That's what we're going to end up with. And you have to apply the rules of common denominator and add or subtract these two fractions, and then flip and multiply and see what you get. You'll see that it works out even nicely for those. It's just a little different technique.
Uh-huh.
All right, Jake, got to run. It's a good session.
Yeah, it was. Thank you.
Yeah, boy, they're moving you quickly through calculus. That's impressive.
Yeah, they are.
Talk to you
Crash
next
course.
time.
Yeah, I'll see you later.
Bye-bye.